Let's look at the following scenario. A point starts at the location 4, 1 and moves counterclockwise along a circular path centered at 2, 1. So our point starts over here at 4, 1, and the center of the circular path is at 2, 1. So here's the center of the circular path, and therefore, when the point starts, it's already 2 units away from the center of the circular path, and therefore the radius of the circular path must be 2 units long. So if we have a radius of 2 units long, we'll just mark out some points so I can draw a circle in here. So our circular path looks something like this. I'm not great at drawing circles, but it'll be roughly something like that. So the point starts over here at 4, 1 and then starts moving counterclockwise along that circular path. And we'll draw in an angle that subtends the path the point travels. So we've got this angle here. We'll say its radian measure is represented by theta. So as the point moves along that circular path, that angle opens up counterclockwise, and theta represents the varying radian measure of that angle. Let's suppose that we're interested in the x and y coordinates of that terminal point. So as the point moves around there, maybe we want to know its coordinates in terms of theta, the number of radians that angle has swept out. So let's just consider the y coordinate in this case. So a y coordinate has something to do with vertical distance, and so we might think of sine, using the sine function. So sine of theta gives us that vertical distance. So that is sine of theta radius lengths. We decided that the radius of the circle was 2 units long, and therefore 2 times sine of theta will give us that vertical distance in units, where units is like the units that are on our x and y axes. So 2 times sine of theta gives us that vertical distance in the units of our coordinate system. However, a y-coordinate is really a vertical distance above the x-axis, and therefore we need to take into account this extra little distance here, which in this case we know is 1 unit because the center of that circular path is already 1 unit above the x-axis. It has a y-coordinate of 1. So just looking over here at this 1, we've got an initial vertical distance of 1 unit above the x-axis, and then the terminal point is 2 times sine of theta units above that. So if we wanted to talk about the y-coordinate, we need to start with the 1 unit, and then we add on the 2 times sine of theta units to get the terminal point's distance above the center of that circular path. And therefore, y will be equal to 1 plus 2 times sine of theta. As theta varies, y will vary accordingly, and this formula always holds true. We could do something similar for x, but we would need to use the cosine function and a different value here. So we would need to think about this, the center of the circle's horizontal distance to the right of the y-axis.